Yeah.
What happens if it goes slideshow? Does it go full screen if it goes slideshow?
Yeah.
Okay.
Yeah, looks good.
Nice. Okay. Well, yeah. Thanks everyone for coming out today and to hang out today. Um, yeah, myself and Chris are going to be representing Quosmo, talking to you about the Neutone project that we've been working on now for I think over a year. I think it's been a sort of incremental journey to where it is now. Got some exciting things to talk and walk you through to do with Newtone and some announcements and stuff at the end as well, which is always fun. So just to give you a little bit of background, so my name's Andrew. I'm an AI application engineer at Quosmo now and a researcher at the University of Glasgow. Just sort of at the tail end of my PhD at the moment, trying to get it wrapped up, but almost there. So, and then Chris, if you want to introduce yourself as well.
Yeah, hi everyone. I'm Chris. I did my master's in Japan, and during that time, I was working with Quosmo, and I spent a year doing kind of a PhD there, and then I switched to doing my PhD at Queen Mary in London. So I just started last September, and am busy with my PhD work, but still, keeping an eye on the open source part of Neutone and working on audio, and I research modulation, so if people are interested in WUBs, that's kind of what I look into.
Yeah. So, saw that bit had a pop-up come up on the screen there. Anyway, so thanks, Chris. So just the agenda to go over today. Again, this is going to be a lot more informal from when we last gave this presentation, which was at ADC last year. So there's been a few changes and modifications to kind of make it more casual, but just roughly the agenda we'll talk you through today is just an overview of the Neutone platform, the core sort of components that make up Neutone, obviously more in depth about the plugin, the features that are available. I've got plugin demo there, but I don't know whether I'll give a demo as such today, and just don't know how it would work out with the Discord Hangouts thing. So it might be more of a video or something like that. But we'll see, and we'll see if we have time. But anyway, and then I'll pass you over to Chris to talk to you more about the SDK, walk you through different components of the SDK, why we built a SDK in the first place, and the different features that exist there for researchers to use, and the resources that are available as well for researchers to get started. And then just to finish off, we'll go and give you some examples of what the community have done so far with Neutone, some contributions, and then to finish off, we'll open up a sort of discursive, informal discussion part where you can ask questions, and also we'll talk about potential models that we're interested in getting into Neutone, like how we can potentially collaborate with others, and then maybe discuss some features from both the researchers and the artist side of what you guys would like to see as part of the Neutone platform. So yeah, just to start off, for those who don't know much about the Neutone project, what is Neutone? I guess, yeah, Neutone is this platform for getting the latest neural audio technologies into the hands of artists, making it accessible and bridging the gap between sort of the artists and the AI researchers that are working on building and innovating these new neural audio models and AI audio models. It's also a platform for AI researchers to develop and test and deploy their models inside the DAW easily, and using a streamlined sort of process and using our SDK, and allows you to share models as well. So yeah, you can share models to us, and we can upload it onto our sort of online model repository, or you can also share between other researchers and load in the models locally as well. So yeah. So yeah, just the community's here. We've got a Discord, similar to Harmonai. We've got a Discord for all about Neutone, the resources that we have there, demonstrations, what the community's up to, and their contributions are there as well. You can get all the resources and the links to the download on the Neutone.space website. So you can head there. and at the moment we've got like download links for like Mac and stuff like that. So we'll you can always check that out as well later on. So why have we built Neutone? I guess like Neutone was born during the time that in the last couple of years where a lot of real-time high quality neuro audio models started to be released. So we had DDSP by the Google Magenta guys, which came out initially, which was super awesome technology. It has allows you to do timbre transfer, tone transfer. Given like an audio in, it will like translate that audio to something else, like a new instrument, for example, and it works very well with like monophonic signals. Then Rave also came out in 2021 by Urcam, and again that was like a 48 kilohertz running like high quality real time VAE model, and allowed you to do like more sort of timbre transfer, kind of style transfer manipulation to your audio signal, and also generate audio as well. And then Rave is more responsive to like transient material, so it's always quite fun to throw like some percussion samples in there and get it to transfer that to like a new sound or something. So we built Neutone round to host these sort of real-time technologies, real-time audio models. Just to give you an example, I'm hoping sound plays here, but you can let me know if it doesn't play. But this is, for those who don't know, like the timbre transfer that I'm talking about. So using DDSP from violin to shakuhachi. So like, can you hear that? Was there audio there? Yeah. Okay, I'm not looking at the Discord at the moment, so I can't see any faces. So I need someone to say that was.
Yes.
They could hear that. Okay, awesome, Scott. Cheers. Okay, and then that goes to something like this. And then same using Rave, so this is from violin to speech. So yeah, that just gives you an idea of some of the sonic possibilities and applications that you can use these models for, which is quite exciting. So at the moment, again, the workflow for actually deploying a neuro audio model in the DAW is quite cumbersome. Requires a lot of expertise, a lot of steps to get there. So we've tried to really streamline this by creating this, this harness, this plugin that allows you to dynamically load different models that have been exported with our wrapper. So so initially, if Neutone wasn't a thing, normally we'd need to build a model, say in like PyTorch, train that model, which again takes time as well. I mean, obviously you still need to train your model to work in Neutone, but again, that's kind of part of the process here. You train your model, then you would typically use a command line application to like then call inference on that model, and it would maybe render out like a WAV file of some result, and you can drag and drop that, I guess, into your DAW and edit it that way. But it's not like that intuitive. It's like not really streamlined. It's you can't sort of iterate on your results and perform with this type of tooling. So that's where Neutone comes in and really shines. So this is just a video here of Big Yuki, who's an artist in Japan. I think he resides in New York. Now it does a lot of cool stuff and lots of live performance. So we worked with Big Yuki to train a model on his voice, and this was the trailer for Neutone. So I'll play this because it's quite quick.
この本には2小節の音楽の断片が多数収録されています。サイコロを2個振って出た値によってこれらの断片を並べていき、一 一つにまとまった感じ。
What's up? Big Yuki here. And man, Neutone is the happy accident. It gives me all kind of new ideas. I can't wait to write some crazy using it. Stay tuned.
Oh shit!
So I've seen that trailer like so many times now, and I still laugh at the end. I just love that moment of like surprise, you know, when he's like just gets some really interesting result from using Newton, and so anyway, it was great to see Big Yuki use Newton in a bunch of live performances and for his compositions as well. So let's talk about the plugin, which is sort of one of the main components of Newton. Here it is here. There's sort of two main windows that you'll see when working with this plugin. I mean, first of all, it's available VST3, AU, and standalone format. So yeah, you can use it in the DAW. You can also use it as standalone, which is potentially useful as well. You know, depends on how you're working and your workflow. But so yeah, we have the model browser. We have a lot of different models on here now, like catalog. We're wanting to continuously expand on this, and you know, we'll talk about that more at the end. But yeah, you can filter through the different models, like filter for the author of the model and type of models and stuff like that, and then you download it and equip it, and then yeah, it takes you to the control panel. So at the moment, it's quite. You know, we have a few different knobs here. The ABCD knobs like hook into very specific parameters to your model. So say you've got some like conditioned parameter on something, you can like map that using one of the custom parameters at the top there. And then the wet, dry, input gain, output gain are kind of, they're more like global parameters, so they're not really manipulating the model itself, but just the routing of the model, so the wet channel, the dry channel, and like how much of the volume has been fed into of the signal has been fed into the model, and then the output as well. So yeah, so that's the plugin at the moment. Yeah, we're supporting DDSP models, Rave. We've got some basic temporal convolutional network models there. We've got my infamous Clipper model. It's not in this picture, but like it's like Clipper. The Clipper model is just a basic like hard Clipper DSP module that I wrote in PyTorch just as a basic template for those who want to start using the Neutone SDK and working with Neutone. So you can see that infamous like example on the GitHub if you want to see how the simplest sort of way of using it. Okay, this is where I do the demo, but I don't really have like the demo, so I'm going to say, well, I'm not going to do an interactive demo on this. So I've got a video, I think, that I might play at the end. Those who want to see it being used for different sort of material and different use cases, but I'll leave it out just now. We did do a demo at ADC, but I'll leave this for now. Maybe revisit it at the end. Okay, so I'll pass it on to Chris now, I think. Is that right? Yeah, I'll pass on to Chris to talk about the SDK. Chris, you'll need to like prod me.
Yeah. Okay, can I just share the screen? I think that's easier.
That's probably a better idea.
Like animations or whatnot, it's probably annoying.
Yeah, that's true. Okay, hold on.
Hey guys, let me just pause for a second. I just want to double check to make sure that the audio is really being recorded. So I'm going to stop the recording and then... it's all working. Great. Wonderful. So I just wanted to make sure that as we continue, so I'm just going to save what I've got from Andrew. Okay, it's going to take forever. But before we went on with Chris, I wonder if this can work in parallel. New screen. It can, indeed.
Multiprocessing for the win.
Yeah. So, yeah, let me just start the screen recording again. And we'll just continue on. Yeah, everything is good. And take it away, Chris. Thank you so much.
Yeah, let me just share my screen. Is that looking okay?
Yeah, that was good.
Okay. Great. All right. Well, I'm going to talk about the SDK because myself and Bogdan and some other people spent quite a bit of time painfully designing this and working with it. So basically, the idea of Neutone is it was really annoying that you have all these great audio models that run on PyTorch, typically, or some Python framework. But then if an artist wants to use it, they have to download a GitHub repo, they have to install a bunch of dependencies, they have to make it work on their computer, and then you have this really unintuitive way of working with these awesome models because you'll run audio through it in some directory, you wait for the model to process, then you can look at the directory and listen to it, and it's just a very broken kind of delayed feedback kind of system. And a lot of creative people aren't even, nobody wants to learn how to set up Python, environments. So basically, this is our way of getting rid of the painful experience of Python. So we thought, we want these models to be used by anyone, and the way to do that is you need an interface, basically, to make sure that people who design the models, the researchers like myself, who can write their model, but typically in some research, spaghetti code, and then try to wrap that in an interface, which then works with our Neutone plugin. And that's exactly what the SDK does. So the SDK for us makes it as easy as possible for you to wrap your model and load it into Neutone. And I'm going to go over some of the key things here. But basically, the way it works is you go to our GitHub, and we have the Neutone_SDK site where it's all open source. You can check out the source code, and you can download the SDK. It's a pip package that you install. And you go through this kind of model development workflow. So it varies from person to person, but it kind of follows this general structure. So you would find the link on our website, you'd visit the SDK, and then you would start building your model, maybe in Colab, because we have example scripts in Colab for training your own Rave or DDSP model, but it can also be in your local environment. So I build all my models in, my IDE of choice, like PyCharm. So then the cool thing is you would load your model locally in the plugin. So from the website, you would also download the plugin and then load it into your DAW of choice. For me, it's Ableton. And then when you start using your the VST, we have this button called Load Local Model. And you can basically load a model from your file system, which was exported in the SDK. So you would write your model in the SDK with a bunch of functions that represent the name of the model, the author, the paper it was based off, and a couple pieces of information we need. For example, we need to know if the input and output are mono, and what kind of sample rates and buffer sizes you're looking at. And then once you filled all that out, you can export it, and we handle all the verification. We check it, we compile it to C++ using TorchScript, and then we create a format that can be loaded by the VST. So then you can iterate really quickly. So this is actually really fun, I find, because I'll make changes in Python, I export it. Exporting typically takes like less than 30 seconds, so you export it really fast, and then you can just immediately start playing with it in a VST, which by itself is already a very big improvement to how I would usually work with audio models, where I would need to load example audio and then, process it and listen to it. So the whole point of this is to change how you prototype audio models, and also lets you kind of iterate faster. But eventually you'll have a model that you're happy with, and you would submit that as a GitHub issue to our open source SDK. And then you just fill out a little bit of information and supply the model that you wrapped, and then we will, run it ourselves and upload it to our S3 servers, which then serve the models to the VST and will be shown in the model browser. So anyone's model can be shared with everyone with the VST plugin. So that's all great. I just saw a question in the chat that I'll answer real quick. But actually, this will be answered in a few slides, but it's about the buffer size. And that's the beauty of the SDK, is it gets rid of you having to think about buffer size. So you'll see in a second why that's the case. But basically, building a universal VST is really annoying and really hard, because VSTs were designed for usually a specific purpose, using typically traditional DSP algorithms. So they're not really meant to wrap some generic Python code. And that is a huge thing that we had to overcome. Like, Neutone goes against a lot of the paradigms in audio programming, because we have no idea what you're going to do with your model. We don't know, how efficient it is, what it's being used for. And the other problem is DAWs have a sample rate and a buffer size that are independent of neural networks, right? So when people load up Ableton, they're not thinking about neural networks typically, or these audio models that require very specific conditions to work properly. We even have issues with, how many channels are there? Input and output, is mono or not? Things like that. So, if you just look at this is all from Ableton. We have all these issues that we need to overcome. Another one is the latency, right? So a model has latency that it introduces, and we need to provide that information to the DAW so it can sync up all the tracks correctly. And that's another challenge, because how do we know what the latency is? If you're at a different sampling rate, you have to resample. We have to worry about CPU usage and what percentage of the time are we computing given the buffer size and how much time we have. We also have to worry about custom parameters, right? How do you control your model? You want to be able to have flexibility, but use an interface that everybody can follow, right? The other issue is TCNs, which are typical, a common audio model for neural audio effects. They often take advantage of these large context windows, right? And this can be, really big, but then it outputs a really small buffer. So you need a look-behind buffer that's efficient and can provide you with the history of the samples you've seen, but then you can output the latest block of audio. So yeah, we're trying to handle all of this in an SDK while making it universal. So basically, you have the DAW here in, I guess, a nice beige color, which can change at any time. That's the other issue. We can't even assume that these things stay fixed, because this is always changing and everybody has different preferences, right? So, for example, you might have 44-100 at 128 samples with a stereo track in, and you're reporting the delay to the DAW. But then when you have a neural network or some audio models, so Neutone doesn't have to be a neural network, but obviously we designed it around these neural models. You would have a constant sampling rate typically that they operate on, so they only work on 48 kilohertz. If you put in a different sampling rate, you'll notice it'll not work correctly. Your buffer size might be fixed, so a lot of neural models require a relatively large context window of 40 milliseconds, so that's 2048 samples in some of these sampling rates. And you can have models that input mono and output stereo, right? You could have a latent space that you sample slightly different points in and get two outputs to create a stereo image. That's a cool application of machine learning for audio. You could have just a mono to mono model, and you can even have stereo to mono as well. So every combination of these channels have to work, and you have to figure out the delay of the model so that you can communicate that with the DAW. And this has to factor in resampling as well, which changes the delay. So while the SDK for Neutone was designed to provide a clear interface for defining neural networks being wrapped with this wrapper, at the end of the day, it must guarantee the model requirements while handling any combination of DAW settings, right? So that's the ultimate kind of challenge that we had to overcome. And if we can guarantee this, then the user who is wrapping their neural network doesn't have to care about the DAW, right? So we kind of provide the bridge between these two worlds of caring about all these audio things and not caring about them and just wanting a guaranteed environment for your model. So we do handle this in a few different ways. Basically, with the sampling rate, we do automatic on-the-fly sample rate selection and adjustment. So when you define your model, you select which sample rates it supports. So you give us the information of this model supports these sample rates. Usually it's only one. And then we will select the best sample rate and automatically resample for you in real time using as little CPU as possible. One of the hardest things was the buffering. So basically we handle all the buffering to automatically guarantee that if the DAW buffer is at a different buffer size, we will queue the correct number of buffers to guarantee you will always get, the correct samples for the model while minimizing delay. Because as you introduce buffering, you introduce delay, but there are ways to choose your buffer sizes such that you have the least amount possible. We do automatic mono stereo conversion. That one's pretty standard. And we do automatic delay reporting. So if you know the delay that your model introduces, we will handle all the extra delay and conversions from the resampling, and the buffering introduces delay as well. So we will handle all of that and account for it and give the DAW the correct delay amount back after everything has been converted. And I'll just give a quick example so people have an idea of how the audio is flowing. So you have your initial DAW settings, and then once you load the Neutone model, you will select your model, and then the model will have a sampling rate and a buffer size that it runs at. So this model runs at only 48 kilohertz and at a buffer size of 512 or 1024. The Neutone wrapper will select the correct buffer size and sampling rate for the DAW settings. And then it'll calculate the resampled buffer size because it's resampling to a different sampling rate, which becomes 139 in this case from 128. And then it'll also calculate the delay caused by the resampling. And this might look like a trivial computation, but it actually has a lot of edge cases where the simple case where it's like one extra buffer is not true. So this actually requires quite a bit more. But if you're interested in this, all of this is open source. You can see how we do it in the SDK. And then we basically have all the information we need to resize and allocate all the internal buffers and queues, which are written in Torch script to be as efficient as possible. So they don't allocate any memory dynamically. We do all the memory allocation beforehand. And then you get your in buffer from the DAW, which might be a stereo buffer. We then bring that into a background thread. So this dotted gray box represents the background thread. This is how we handle a lot of this. So we wrote all of this in Python to give the user flexibility about, you can override the resampling, you can override the buffering, you can do whatever you want in Python as long as it compiles to Torch script. And then in the SDK, we handle all the multi-threading and run the Torch script in the background thread to be as, real-time safe as possible. So then this gets converted to a mono buffer, which, because our model is a mono model and output is stereo. So this is just an example. So we'll convert to mono automatically. We will resample it and put it into a input queue, which is of mono audio. So this has been resampled, put into the queue, and this queue handles the buffering to make sure the model always gets the correct amount. The model then does its inference. It outputs the audio, which is now stereo, into an output queue. This gets then resampled back to the correct sampling rate for the DAW. And then this gets sent back to the DAW at the very end. And if we've done this correctly, this has been done in one block of computation, or sometimes more than one, depending on your model and how heavy it is. All right. So yeah, I see the question here of how do we handle with rounding issues when resampling. And basically right now, we basically round to the latest interpolation. Yeah, so as Andrew said. So right now the resampling is linear interpolation because it's super fast. In practice, we found it works really well. I do have a proper, sync anti-aliasing resampling also in the works. The only issue is getting that to not allocate memory dynamically is still a little painful. So if there's demand for that, we can definitely add it. And the user has the freedom to, write or implement their own resampling. I've been toying with the idea of adding just a a little bit, like a bilinear or something like that. But basically, other resampling methods are definitely possible and have worked. They just need to be fine-tuned and added to the SDK. And yeah, the rounding issue, I guess I thought about this where we should keep track of kind of our errors and round up and down intelligently across the buffers over time. But in practice, we haven't found this to be an issue at all. Like rounding to the nearest integer has been more than fine, but that's definitely something that could potentially be improved. No, we don't get any clicks from that. So the other reason for this is because our resampling matches the edges of the buffer size, so we don't get a click between the different buffers. But yeah, that's a good point. What else? Yeah. So then the SDK has a few other benefits, which includes common utility functions. So writing models in PyTorch is really nice. That's why people like using PyTorch. But writing models that compile to C++ well and don't allocate memory dynamically and are easy to profile requires you to write Python kind of like C++. It's really weird. So if you look through the open source SDK code, you'll notice the way a lot of the Python is written is a little bit different than if you were just building your own deep learning model in PyTorch, and it's usually for a very good reason. So one example is in PyTorch, if you're moving a tensor over by a few samples, you would just do torch.roll, but torch.roll is not supported by TorchScript. So you're kind of out of luck there. So you need to write the ugly kind of manual moving the tensor around. So it includes some utility functions that are really helpful that you don't need to write yourself. So like we have cache convolutions, we have TCNs. We have a super efficient circular audio queue, which doesn't allocate memory and basically does as little operations as possible. And this helps us a lot with the overhead. We have a look behind buffer that, once again, you could write yourself, but if you do, you will almost definitely the first time around introduce extra latency and potential dynamic allocation. So we handle all of that for you, and it's only used if it has to be used. So a lot of these things don't activate until they're required. So it also saves you CPU cycles. And we provide a little profiling script where you can check how well you're doing and where you're spending your time on. And I've spent a lot of time looking at the profiler, so it's been great for that. And the other benefit is, it's compatible with most DAWs. You can load your models locally, which lets you iterate really fast. And I think a really cool thing is you can map your parameters to a MIDI controller, so you can control latent spaces with your hands, which is really hard to do on a computer. So that's something I didn't really think about much because I'm more of a software person, but people I know who prefer, hardware synths really appreciate being able to play with neural models with their hands. Like, if you think about it, you can't move two knobs at the same time with a mouse, but you can with your hands. It's amazing. These input devices are ahead of their time. So that was kind of a cool thing because, when people use this, they do things that you don't expect, which is great. Another thing I want to point out is the Spectral Wrapper. This is actually from a very long time ago. I wrote this wrapper that handles the spectrogram conversion for you. And it does so causally and, handles a bunch of edge cases and will convert it back as well. I'd like to get this into the SDK just to make it easier to work with spectral models. Some people prefer images, and they can be a lot of fun. And writing this yourself is a huge pain in the ass, so we'd like to include that in the SDK, and that's kind of a work in progress at the moment. And an example model that I like to show with it is I have this it's a really nasty spectral distortion. It absolutely obliterates your sound, but it's kind of fun for some use cases. So that could be a good use case, but I'm sure other people can think of better spectral audio effects. if you're interested, you can check out the SDK Colab notebooks. So they're on the SDK website. Just go to the website, like the GitHub, and there'll be one of the first two links, and you can train your own Rave or DDSP model. All you have to do is follow the examples on the Colab and include a folder of training data or something like that. And that makes it really accessible to work with these two kind of popular models that we have on Neutone. Yeah, I guess, should I hand it back to Andrew at this point? Or should I go through these examples first?
I mean, yes, you could show a couple of the examples.
Yeah, let's have a look. So these are just a collection of some of the stuff we've seen the community produce. See if this plays.